In this lecture, we're going to look at firms' costs. So really what we're going to do is translate the costs of firms purchasing inputs into measures of costs that firms would incur for producing certain levels of output. So we can consider what costs firms would consider in the short run and the long run, and we'll talk about what those two definitions mean. And then we're going to define a lot of different equations for costs, and these it will become more apparent why we care about these different costs when we talk about firms operating in perfect competition and other market structures. So we're going to define variable costs, fixed costs, and total costs, marginal cost, which will be a very important concept, and then we will look at the average variable, average fixed, and average total cost. And what we're going to end up doing is plotting the AVC, AFC, ATC, and marginal cost on a graph and show how they tend to change as the quantity output changes. So that's really going to be what we're building to in this lecture. Okay, so when firms are in the short run, remember we had fixed and variable inputs. Well, we can change that around to look at fixed and variable costs. So variable costs are basically the costs associated with variable inputs, and these are costs that are going to change with the rate of output, and these are costs that firms can vary in the short run. Fixed costs, on the other hand, are costs that do not vary with output. These are not costs that firms can change in the short run. So firms are going to incur these costs even if they don't produce anything. So you could think about if you signed a long-term lease for a building, if you signed some long-term contracts where you're going to purchase certain materials no matter what. These are fixed costs. You incur these costs no matter what in the short run. So total costs are just going to be the sum of the variable and the fixed costs. Now, when we get to the long run, then all costs are treated as variable costs. So in the long run, firms can vary both things that are fixed in the short run and obviously vary things that are variable in the short run. So in the long run, there are no such things as fixed costs. Every cost is variable. So what we can start to do then is turn those three cost measures, variable, fixed, and total from the last slide, into averages. So what we can do with total cost is we can take total cost and we can divide it by the quantity output, and that gives us a measure of our average cost per unit output. And we can do the same thing with variable cost and fixed cost. Take however many variable costs we have for our level of output, divide that by the quantity, that's our average variable cost. For fixed costs, take our fixed costs, divide them by our quantity, that gets us our average variable cost. And then we have marginal cost. Marginal, again, think change. So marginal cost is the change in my total cost if I produce just a little bit more. So we can change all of these things into formulas. So if I want to find my total costs, this is how I can do that. So my total cost is I take my variable costs plus my fixed costs. If I want to find my average costs, this is how I do it. Average total cost, I take my total cost divided by the quantity. Average fixed cost, I take my total fixed cost divided by the quantity. Average variable cost, I take my total variable costs divided by the quantity. Now, one other important thing to keep in mind is, remember I had this formula for my average total cost. I also have this formula too. So if I take my average variable cost, add on my average fixed cost, then I also get my average total cost. So lastly, here's my formula for marginal cost. Again, I take the change in my total cost divided by my change in my quantity output. So almost all the time when we talk about marginal cost, we're going to be talking about change in quantity or change in cost if we output just one more unit. And then also there's something special that happens with my average fixed cost. It will always be declining as I output more units. So why is this? Well, remember my total fixed costs don't change. So as I increase my quantity, this bottom part of the fraction is getting larger and larger. So I'm dividing the same number on the top by a larger number on the bottom, and that means that this resulting number is going to get smaller and smaller. Okay, so let's look at a table of all of these things just to kind of see how they are all related. So at the top here I have different costs and then the formulas for how they're calculated, and then this column way over on the left is just the quantity that I will output. So here we go down. Okay, so let's get started. So my total variable costs here are just going to be for a given quantity, how many variable costs are I incurring to produce this quantity. So that's this column here. My total fixed costs, again, are not changing, right? So that's why they are called fixed. So no matter how much I produce here, whether it's 0 or 100, my fixed costs are still the same. Variable outputs change. Then my total costs I find just by adding my total variable plus my total fixed. So notice 30 plus 100 is 130, 300 plus 100 is 400. So next I can look at my average costs and then my marginal cost. So I'm not going to compute these things when I have no output because these three will obviously be 0 because I'll divide by my quantity of 0, and that doesn't really make sense. So let's look at average variable cost. What I do is I take my total variable cost here, 30 divided by 10, my quantity, that gets me 3. My average fixed costs is I take my fixed cost here, divide it by my quantity, and then note that this is always decreasing. Now my average total cost, I can either add these two columns together, or I can take my total cost and divide it by my quantity. So before we get to marginal cost, I just want to draw your attention to the 3 numbers in red, which represent the minimum values for all these costs. So note that the minimum value for average variable cost falls somewhere in the middle. So average variable cost starts decreasing, it reaches some minimum, and then it increases again. The same thing happens for average total cost, but not for average fixed cost. So remember, average fixed cost will be always decreasing. Total fixed cost is the same. I'm dividing by an increasingly large Q, so this will be always decreasing. So AVC and ATC will be U-shaped. We'll talk about that more in a little bit. So then lastly, we're going to talk about marginal cost. So how I find marginal cost is I look at the change in total cost, or total variable cost here, same thing, divided by the change in quantity. So let's look at this. So here we go 0 to 30, or 100 to 130, and that is a change of 30 divided by a change in 10, that's $3. Same thing I could do here. This would be 30 to 50, so that's a change of 20 divided by a change in 10, that would give me 2, so on and so forth. Now note here too that marginal cost also reaches minimum. So marginal cost is also going to look U-shaped. Okay, so let's start to graph these different costs. So first we're going to graph the total cost curves. So the way that we're going to draw our graphs now is on the y-axis. We're going to have measures of price or cost, basically dollar amounts. Okay, and on the x-axis, we're going to have quantity of output. And this is going to hold true for a long time now. So just get used to seeing y-axis of price, x-axis of quantity. Same general setup of the axes as when we talked about the supply and demand model. So my total cost curve will look something like this. My total variable cost curve is going to be below it. And my total fixed cost is going to be constant at $100. So then you can note that the difference between the total cost and the total variable cost, the vertical distance between these two curves, is always going to be $100. That's because total cost is equal to total variable cost plus total fixed costs. So note that my costs increase, they kind of stop increasing quite so quickly, and then they really start to shoot up. Okay, so how about graphing my average costs and my marginal cost? And this is really what we're going to find is really important when we're talking about profit maximization, competitive markets, so on and so forth. So we can start by graphing my marginal cost curve. Here it is, it's U-shaped. It has a minimum of $1, and then it goes up. Here we can graph average variable cost. Here we can graph average fixed cost, always decreasing. And then we can graph average total cost. So there are some important relationships that I want to draw your attention to. First, look at where the marginal cost curve crosses the average total cost curve and where it crosses the average variable cost curve. It crosses both of these curves at their minimum possible values. You can see that if you go back and look at the table in the previous slide. So this will always be true. And this will also be very important in the upcoming lectures where we talk about perfect competition. So this is a general relationship, general depiction of how these curves are going to look. Average total cost curve is U-shaped, so is average variable cost. Average fixed cost is always decreasing, and marginal cost is also U-shaped. And again, marginal cost always crosses AVC at its minimum and ATC at its minimum. The vertical distance between ATC and AVC is equal to AFC. You saw that from the mathematical relationship a couple slides ago. So if I took this plus this, I would get, at every quantity, I would get the ATC. This AVC plus this AFC should get us to the ATC. So here's something to remember, to just remind yourself that the marginal cost curve will always cross the average variable and average total cost at their minimum. The average follows the margin. So if the marginal cost curve is above the average, then the average is going to increase. If it's below the average, then the average is going to decrease. So think about two examples. We can look at average scores on a test, and we can look at LeBron James. So let's say the average score on an exam is 85%, and then Smarty McGenius joins the class and gets 100% on the exam. So the marginal score is 100%. What's going to happen to the class average? It's going to go up. Well, what about Lazy No Studison? She joins the class and she gets a 34% on the exam. So here in this case, the margin is 34%. The margin is below the class average. Well, the average is going to fall. Think about LeBron James. His average points per game is 30. If he has a game in which he scores 45, his average points are going to increase. If he has a game in which he scores 12, then his average is going to decrease. So why are these cost curves U-shaped? Well, it goes back to diminishing marginal productivity. So if you think about how at first when we had inputs, they were very, very productive, and then they became less and less productive, well, that has an inverse relationship to the cost that we must incur to produce one more output. So diminishing marginal productivity leads to these U-shaped cost curves. Okay, so that's the short run. Well, the long run, again, all costs are variable. So really what determines long run costs is the size of the production process and what are called economies of scale. So we had that U-shaped average total cost curve, and it falls as our production expands, and then as it reaches its minimum, that's when production is most efficient and cheapest, and then it starts to increase. Well, we can look at that at the long run too. So if we're in a situation of economies of scale, then if firms expand, then their average total cost is going to decrease as they produce more. So what that also means is larger firms are going to be more efficient than smaller firms. Well, we can also have the opposite, diseconomies of scale. So this is going to be a case where if firms expand, their costs will rise. So large firms are less efficient than small firms. With constant returns to scale, you expand, your costs don't really change. So a good example are chain restaurants. If Olive Garden expands, opens another restaurant, their costs per restaurant are pretty constant, so their costs aren't really going to change. So what this leads to are long run average cost curves that start for low levels of output looking like this green line here, and then as output expands, well, we could either continually have decreasing returns to scale, in which case the long run average total cost curve will decrease. We could have constant returns to scale. They could be constant here, or we could have increasing returns to scale. Wow, that was totally backwards. So what will our cost curve look like in the long run? Well, in the long run, there are three distinct possibilities: economies of scale, constant returns to scale, and diseconomies of scale. So at first, each long run average total cost curve exhibits economies of scale as a result of increased specialization and using mass production techniques, purchasing power, etc. And then we get to this point here, and then we could have our three different options. So we could have an industry with economies of scale. So these might be like utility companies. So the cost curve will continue to, the average total cost curve will continue to decrease as we produce more. We could have constant returns to scale. This is like Olive Garden, where as we increase our output, our average costs are pretty constant. Or we can have diseconomies of scale, where as we produce more, our average total cost curves start to increase. So we could finally compare short run and long run cost curves. So the short run cost curves are both U-shaped. However, they're U-shaped for different reasons. In the short run, we have U-shaped cost curves because of diminishing marginal product. This is marginal product of labor falls, marginal costs rise, and then the ATC follows the marginal cost. In the long run, U-shaped cost curves are all about economies or diseconomies of scale. So what we have are situations where maybe smaller firms can grow and lower their costs, but if they get too big, then their average total costs can rise.